Here's a few examples of some of the questions we were doing a couple of days ago. So it's just about similar triangles. Now what you've got, quite often they actually show you a shape in which it's actually two triangles over one overlapping the other one. Okay, so don't think of this as being a separate shape. What they're trying to do is they've got one big triangle and a smaller triangle, okay, overlapping it. So the good thing to do is to actually just redraw these triangles out. I'll try and do it neatly with this. Redraw these triangles out. Again, this isn't to scale to the one above. And then just write down the measurement. So that's 7, that's 15, and I'll do the smaller one. So that's A, and that's 3. Now, what they're trying to, well, what they're asking you is to actually work out what A is. Now, they're similar triangles, so these angles are going to be the same. So that angle is going to be the same as that angle, and the proportions of the sides are going to be the same as well. So how you actually work out this side is we actually need to work out what the scale factor is. Now, this is essentially before it's been scaled, okay, and this is what it looks like after. And the one in which there's an unknown, think of that as this is what the shape's now be changed to. So to actually think about working out a scale factor, we want to think of, well, it's gone from bigger to smaller, so it's a reduction scale factor. And all we do with this one is we actually look at the sides in which there's an actual value and look at the corresponding sides of the other triangle. So if we actually look at this side, for both triangles we actually have a value. So that will allow us to actually work out what that's been scaled by to get from 7 down to 3. Okay, so it's been multiplied by something. So what we do is that equals, we can just say it's almost as what it is after the scale divided by what it was before it was scaled. Okay, and with that, that is 3 over 7. Okay, now if it's going to be getting reduced, okay, so that's obviously been reduced in size, then fraction is going to be smaller than 1, because any number you multiply, if the number you're multiplying is smaller than 1, it's going to be a smaller number. So what we've now got is we've now got the scale factor. Now to work out what A is, we just say A is equal to the sides, the corresponding side of A that we do have the value of, so that's going to be 15 times 3 over 7. Okay, so it equals the value of the corresponding side times the scale factor that we've just worked out. What you'll have is your calculator, so I'm just going to say just 3 divided by 7, and then I'm just going to say times 15. And I'll just say 6.43. So 6.43, and that's in centimetres. So that is the size once this scale factor's been applied to it. Okay, what you'll probably find is if you divide this scale factor, or sorry, this value by 15, it should be roughly about this scale factor. Okay, I know it's gone from fraction to decimal, so there'll be a slight wee change. But that's essentially how you do it. So if you look at a picture in which is one triangle overlapping another, it's always good to actually split them up, and then you can work it out easier. So if I look at the next one, so what we'll have, again, we've got two triangles, so let's split these up. So we've got one triangle, I'll get rid of that error, one small triangle, that's 5 centimetres by 2. If I could spell 2, that would be a good start. So that's 2 centimetres, and that's 5 centimetres. And then we've got the bigger one, and obviously it's not to scale itself, and that is 5, and we're actually wanting to work out what the large side is. So that's B. So if there's a side that's unknown, that's what it's now been scaled to. So I'm just going to just, like the last one, I'll say that's before the scale and that's after. So obviously you can see here that's going to be enlarged. So what we can do is we can say this is the enlargement scale factor, and again we can say it's what it's been changed after the scaling, divide by what it was before the scaling, and we pick a side from each triangle, and it's a corresponding side that actually has a value to it. So if we look at here, we've got 5 and the corresponding side is 2, so we say that's 5 over 2, and that's 2.5. So we can actually say that this is 2.5 times bigger than this. So let's work out what b is. So again, all we do is we say, well, b is, if this side has been multiplied by 2.5 to get to, from 2 times 2.5 gets you to 5 centimetres, we're just going to multiply this side by 2.5. So we're going to times that by the scale factor of 2.5, and that gives you 12.5. Obviously, just double check these things just in case you make a wee mistake in the stress of an exam, right? Like I seem to be doing, times 2.5. Aye. For some reason this isn't working at all. Times 2.5. There you go. Right, so that's essentially the long way of doing that. Right, but that's how you work out one of the unknown sides, and obviously I need to practice what I preach and give a wee centimetre unit as well. And the very last one, let's have a wee look at this one. Now this is a wee bit different because you're looking at this value here. So we're looking down and it says something about a C, so we need to wonder what this C is that they're looking at, okay? So what we need to do is, again, we just draw these two triangles out separately. So we've got the small one, and that's going to be 5 centimetres, and that is going to be 6 centimetres. We have the larger one, again, it's not to scale, but just to illustrate, 8 centimetres. Now we need to actually work out this length. If we work out this length, we know that this length subtract 6 is going to be C. So we'll just call this, I'm just going to call this D. So essentially D is going to be from here down to here. So this is just a new thing we've introduced, right? So that we'll call that D. Right, so again, what we're doing, this is obviously before the change. This is going to be after it. So again, we look at a corresponding side from each. So we'll say it goes from there to there, so that's going to be an enlarged scale factor. So that, again, I'm just going to keep to this after over before. You don't need to worry about that, just to make sure that you're understanding how it works. So 8 divided by 5. Okay, so that's a scale factor, 8 divided by 5. Right, so that's obviously increased the size. So if we now work out what D is, so we can say D is, now it went from 6 centimetres, it's been multiplied by 8 over 5, and then we just work out what that is. Okay, so 8 divided by 5 times 6 gives you 9.6. Okay, so this side D is 9.6 centimetres. Now that's not quite what they're asking, they're actually asking you what C is. So basically C equals your 9.6, subtract your 6, so that actually equals 3.6 centimetres. Okay, so again, just to say, with these, if it's one shape on top of the other, just split them out and then you'll be able to work it out a lot easier. So you visualise them as two separate shapes. And that's hopefully helped you with similar triangles.